So recently I was traveling in a train when I lost access to the internet. And at that time I was on GitHub, and instead of the default offline page, I got a custom one. And then I was like, hey, hang on a minute, what's going on here? Then I realized that they did that with PWAs. And in this video, using Ruby on Rails, of course, I'm going to show you exactly how GitHub did that. In other words, I'm going to show you how to save custom offline pages to your users on your Ruby on Rails application. But to start, I would like to show you exactly what I meant. And so we have the sample page here on GitHub. I'm going to simulate an offline page here by going to the DevTools, going to the application, and then saying offline. And then we can click any link here. And then here we have your offline with the GitHub logo. And it looks simple. It gets rid of the default custom offline page. And this is exactly what we are going to build. Here I have another browser that's running a PWA enabled Ruby on Rails application. So I have everything set up. I have another video to help you set up your PWA from scratch. I think I'll link it somewhere on the screen or in the description if you want to check it out. So this is a PWA enabled application. It does nothing at the moment. So what we have here is, say we have an application that accepts a string for a name of a book. We can go back to books and whatnot. But if I try to simulate an offline interaction with the application, this is what I get. You get the default offline page that the browsers provide for us. This, by the way, I learned a few years ago that it was a game and that you can play by pressing the space key. And with PWAs, you can actually do the same thing for your application, in the sense that you can develop an HTML application, an HTML and or JavaScript application, and save that instead of this game. And there are several use cases why you would want to do this. Another one that I could think of is, if, for instance, if you have a product page, you could actually try to keep the user busy by answering FAQs or showing them more about the products, showing them things about the products that will keep their time while they are offline until they get back online. You can also use PWAs to actually prompt the user while you're keeping them busy, prompt the user when their internet is back, when their connection is back online. So without further ado, we are going to dive straight into code here. Here you can see that I have some code to register my service worker, which I've commented out. And inside of this service worker JS, we are going to do the real work of serving the custom offline page. But before we move on to the next steps, this is what I actually wanted to show you, that we have an offline HTML file, and essentially it has a center tag and an image tag that points to an image that we are going to save offline. So the image in question now would be this that I quickly made for the purpose of a demonstration. So this is what we are going to save when the browser detects that the user is offline. Currently, if we simulate an offline page, we get this, and this is quite ugly and it's everywhere. You want to provide a very rich experience to your users. So we are going to fix this. So now that you've seen what we are going to serve, we can just get straight into the service worker. And then after doing all the magic inside of the service worker, we can just uncomment this code here to have our service worker registered by the browser. So the first thing we need to do is to actually set up a value that we are going to use to invalidate the service worker. So with service workers and the browsers, the browser, once it has installed a previously installed service worker, anytime it detects a change in the service worker file, it would be forced to reinstall whatever. It would be forced to reinstall whatever is inside of the service worker, essentially parse and execute the service worker file. So in this file, you can see that I have offline version. This constant we are not going to use for anything. We're just essentially going to increment it to force a change anytime we make a change, so that the browser reinstalls our service worker. Then we have a cache name. The cache name is offline, and this cache is what we are going to save the offline information that I showed you a few seconds ago. That would be the offline HTML and then the image that I had created earlier. So that's where we are going to store this. This cache is where we're going to store all of that information. And then we have an offline URL, which is the URL that fetches the content that I just showed you, the offline content that I just showed you. The reason we have this here is that we want the service worker to be able to have a way to download the offline information. That's the offline image and then the offline HTML. And then the main things that we are going to be focused on is 3 events inside of the service worker. These events of interest are the install event, the activate event, and then the fetch event. So the install event, what it does is once the application has detected that we have a service worker registered, it's going to pass the service worker file and then look for and then trigger the install event, and whatever is inside the install event would be installed. And then after installing our service worker, of course, we want to activate it. And then after activation, we are going to listen for a fetch event, which is an event that is fired when there is a request inside of the application. So what we are going to do now is to uncomment the first event and do some work here. What we are going to do here mainly is essentially fetch the content of the offline URL and then save it inside of the cache and then save it later on. And the way to do that is, first of all, we are going to do events.wait until, and then inside of this, what this method tells the service worker is that it should wait until everything inside this block is run before moving on. So we want to extend the lifespan of the install event and then tell it to wait until whatever we want inside here is done before it can move on. In this case, we just want to fetch the offline content and then save it to a cache and then return that object. So once we have the wait until method, we're going to do caches, open, and then cache name. And then we are going to say then, and then inside of this, we are going to have our callback function here. So we will have this, and then we will call this cache. This would be the cache object that we get from opening the cache that we created, or opening the cache that the cache is open creates. The cache is open creates a cache object if the name passed away doesn't exist. All right. So in this case, if cache name already exists, we're going to open it. If it doesn't exist, it's going to create and then open it. So with this, we can just do return and then say cache.add, create a new request, and then pass it the offline URL, and then pass it an option that we'll call cache reload. We need some some screen real estate, so I'm going to disable this sidebar here, and then we're going to have wait until cache is open. We are going to open the cache, get the cache object, and then add the result of the request to the cache. what this option does is that it tells the service worker to fetch a fresh content from the web instead of fetching it from the local cache. That's if there's something in it already. So we are going to always fetch the fresh content from the web first, and then if we get nothing from it, we are going to fall back to whatever is in the local cache. So the name of the cache would be the offline URL, and the content will be the response of whatever comes out of this. And then we are going to say self.skipWaiting. And the reason we're doing this is that this method forces a service worker to activate immediately, bypassing the waiting state. The reason we want to have this is you could have several tabs open, and there's always only a single instance of a service worker, and if there are several tabs open, that one single instance of the service worker controls all of that. If we say self.skipWaiting, we are forcing the service worker to activate immediately, irrespective of what's happening in the other tabs that this single service worker controls. All right, so we are done with this. The next thing we want to focus on is to get to the activate event and listen for it. And inside of this, we are also going to do wait until, which I've explained previously. So we are going to do something like wait until, and the wait until, like the first one, it always accepts a promise. So we are going to create one and then resolve it immediately. So what I'm going to do here is I'm going to do promise.resolve, and then I'll say then, and then here I can have inside here a function that checks if the browser accepts navigation preloads. This is not really necessary, but it's sort of like a best practice. And after writing the code, I'll just explain what it does. Just give me a second. So we have self registration, and then navigation, not service worker registration, but registration. And then we have navigation preload. So once this is done, we can add another method here, which would be clients dot claim here. Okay, so before we move on, let's see what's happening here. We are returning a promise inside of the wait until method. What this promise is going to do for us is it's going to perform a check, and the check is that it checks if the browser supports navigation preloads. And if it does support navigation preloads, we are going to enable it. Navigation preload is a feature inside of our browsers that's used alongside service workers. And what this does for us is, if you have a service worker with a lot of stuff happening inside of it, sometimes the browser would be blocked and then wait until whatever is happening inside of the service worker is completed before moving on to doing whatever it wants to do. This is not ideal for performance. So if you have a lot going on in your service worker, what you can do is to enable navigation preload. And what it does is that when the service worker boots up, it can in parallel do like fetch other things that it needs to fetch instead of having to block the browser and do its fetching. So if you're fetching a lot of contents, you can do enable navigation preload and say that while the service worker is booting, it can in parallel fetch contents for your service worker so it doesn't slow your application down. Clients.claim method is more often used with the skip waiting method, and what it does is it forces the service worker to immediately take control of all active pages within the scope of the service worker. So we want to make sure that we are using this in conjunction with skip waited. And now we can move on to the last event of interest, which is the fetch event. And so here we are telling the browser that if a fetch event comes in, it should respond to whatever we are going to provide it with here. So here I'm going to do event preload response, event preload response. Did I type that correctly? No, there should be an S here. And then we're going to say then, and then preload response. This would be a function. And then inside of this function, we are going to check for a response inside of the preloaded response. So we're going to say preload response. If there is a preload response, we are going to return that preloaded response. So preload response here. And then if there isn't a preloaded response, we are going to fetch it from the network. So I'm going to type fetch, and then I'll say event.request. And if all fails, we are going to catch this and then respond with an error message inside of the console. So what I'm going to do is I'm going to catch this with this response here, and I'll call this error. And I think there's something wrong here. So catch async, okay, yeah. And I'm going to do console.log, and I'm going to say fetch failed. And I would put in this error here. And then here, this is the bit where it gets interesting. This is the moment where we are going to respond with the stuff that we have inside of our cache. So I'm going to say caches open cache name, which is what we had previously, and then we are going to grab that cache object and then return it. So we're going to return cache match our offline URL. So the offline URL is how we named our cache object, our cache response. So we did that here, and we created a new request and then called it offline URL. And then it's actually a key value store. So the key would be the offline URL, and then the value would be the response of the content of this request. So we know the name of our cache is offline URL, which would be offline.html. And so if everything else fails, if we don't have a preloaded response and we can't fetch from the network, we want to respond with whatever matches offline URL inside the cache. So once this is done, we can test if everything is working fine. But first, we need to make sure that we are registering our service worker. So I'll go into my Brave browser and then see if everything is working. There might be something wrong, but then that's why we have debuggers. We're going to debug it. So I'll do this, and then I'll say we should go to our main application page. So once you're on the main application page, we can try to simulate an offline interaction. So here I expect that the browser will return the contents that we saved earlier, the custom offline page that we saved earlier. So I'll do new book, And there you go. We have your offline or your off the rails. Check your Wi-Fi connection. So if we click this and then go back, we should expect that our application is working. So that's it. That's how to serve custom offline pages with Ruby on Rails and PWAs. I hope you enjoyed it. If you did, I would appreciate a like and a subscription. And you can comment and ask questions, and I'll see you in the next one.